Hey everybody, welcome back. So let's go ahead and actually make this robot move a little bit. So what you see on top here is arguably one of the most important tools that you're going to see in this one, which is my little stand for the robot. So what we're going to do before we run any of this code to make these wheels move, what we're going to do is put this robot up on top of this little container. Now, be careful because you see on the bottom our line following sensor, right? Uh, don't put it on that because that'll break it. So, what you're going to do is just going to kind of take the middle of that robot and put it up on there. So in FRC for robotics, what we use sometimes, well, in Team 5555, we do not use dynamite sticks anymore because we had a really bad experience one year. Yep, that was exciting. Power ups. We hit the wall so hard it was ugly. Anyways, what we're going to do is we're going to kind of just keep that off the ground, off the desk a little bit, because if you start moving the wheels, the robot is obviously going to fall off of the desk if it is moving. So we're just going to go ahead and prop that bad boy up on there to make sure that it does not fall. But we can actually run it still before we start running it all over the ground. We want to make sure that we check the code in place here to see if it actually works. So the other thing that you're going to need in this is that I'll put a link in the video to the file we need. So we have our robot starter here kind of set up. And what I'm going to do, I'm going to decrease the size of, well, it's a little too small, huh? I'm going to decrease it to be about half of the window, maybe a little less than half. And I'm going to link in the video to a file called Auto Go. So this is a file actually provided by Elegoo for this particular robot kit. I'll try and link the Elegoo stuff on the video as well. But like there's this whole table. So like in the middle, let's see if I can show you that on the robot real quick. You have, you can kind of see it in there a little, well, maybe not. But you have the motor shield, which is kind of similar. You can kind of see it in there, I guess. I don't know. You have the motor shield in there, which is kind of the same as a motor controller would be in regular FRC robotics, like a Talon or a Victor or one of those things. The 298N, L298N, is actually exceptionally common motor controller for Arduino. It does not necessarily do all the fancy things, but it definitely does the job that we need it to do. And what this Auto Go file is doing is it's kind of setting up that motor shield and setting up all the stuff that we need to actually make the wheels move. So there's a lot of stuff. There's like this whole table and like there's a whole bunch of different pins and things that it needs. This kind of explains it all. And once you get into it and you kind of see it work, maybe that'll make a little more sense. But that's a lot of stuff. And what we're going to do in here is we're going to kind of pick and choose what we need a little bit. And we're going to do a little bit of commenting as well. So let's go ahead and pick and choose first. The first things we need some definitions here. So what we're doing is we're defining what pins on the Arduino are being used. So you can see that on Arduino, all the pins are labeled. Let me see if I can kind of show you that as well. I'll show you on the simple Arduino that's separate of the robot here real quick. You can see on the side of it, this one's kind of used, I suppose, that you can see everything is labeled with numbers. So what they're labeling here is what pin numbers correspond for the motor shield. So they're saying 5, 6, 7, 8, 9, and 11 are the pins that are used for the motor shield. So we definitely need to go ahead and select this thing right here And we're going to just go ahead and put that up towards the top of our starter robot program, because that is important to define which pins are used. And we're going to go ahead and skip. So there's a lot of stuff. We're going to get back to some of this stuff later. And I'm going to put it in a little different way than they do. So the first thing we do, we have our serial communication. And now we have our pin modes right here. So before we do anything with moving the motor, so we're going to comment right here. This is going to be set up motor pins. And then we're going to go ahead and we're going to put those pin modes for our 1, 2, 3, 6 pins that we require in our setup. So we have our setup here. The top part we have start serial. Sorry, you're watching me type a little bit. You should probably spell things right. I don't always do that. We're going to set up our motor pins in there. So the next thing we need to do is that we have that whole table kind of up at the top here. Let me make this a little bigger. That shows like exactly what happens with each pin is set to low or high. Well, that's nice use. It's somewhat useful information, but there's definitely a better way to do this. So what they've done is they've set up some functions here. So like in robotics, you would have like a tank drive or a curvature drive, or a whole bunch of different drives. This is kind of the Arduino version of that. So we have basically forward, back, left, and right. So we're going to take from our void forward all the way down to our void right. And we're going to take that from our auto go, and we're going to go ahead and we're going to take this. And I like to put my functions after the loop right here, because that way I think they're kind of a little bit more out of the way. And you don't have to scroll through all that stuff to kind of get there. So we're going to put down here a comment that says we're going to define our custom functions. And then we're going to put those down here. And we're going to change some of the names here as well. So we're going to say this one's going to be drive forward, drive back, turn left. We'll say turn left. And then turn right will be the last one we copied in. So again, just to kind of recap where this stuff came from, in our auto go, you have these functions, void right, void left. And we just kind of took them from our example here from auto go, and we put them into our own kind of template. So I think they're going to be easier to use like this. We put them after the end of our loop, and this is where our custom functions are right afterwards here. So you will notice a couple of things. You have the pins that are all set properly, and then you have a print for what direction it's going. So we have the serial communication working. We have all of our stuff set up. Let's actually go ahead and start making these wheels move just a little bit. So one of the things in a program that you always need to do as well is do Control S. Save your file frequently. That way you don't lose it and everything is good. So in our loop, so we have our pin modes all set up. What we have in our loop, we can erase I'm in a loop like I promised. And what we're going to do is we're going to say drive forward. Then we're going to say delay for 1,000. Drive. And oops, we want to say drive back. And then we're going to just reuse our delay of 1,000. So essentially, what should happen is we should drive 1 second forward, 1 second backwards. So just like we've done previously, in our tools, make sure your port is selected. Should be the same as we've done before. And then just do Control S, save it. And let's go ahead and do just a quick check mark real quick. So what this does, essentially, it makes make sure we didn't screw up. So this is to verify our program so we know that it's going to work well when we upload it, as opposed to hoping for the best, which is, to be honest with you, what I usually do. So if everything works the right way, what we should do, if we go over to the robot, we should see our wheels move forward and then backwards. Now, one other thing that is going to kind of hold this up is on the back of your robot, you have that on-off switch. You have to make sure that the on-off switch is actually turned on. Otherwise, the robot motors will not have enough power to run, and this will not work. I'm going to go ahead and flip the video real quick, actually. So forward should look like forward and backward should look like backward, I think. Hopefully that will work. So let's go ahead and hit the magic button. And we see forward, back. We have actual wheels moving. Isn't it so happy? Now, if for some reason your wheels do not move, by the way, you can always, if you look, you can always flip the off switch to make the wheels stop moving, just to kind of make the craziness stop. If your wheels don't move, there's a couple of things to double check. Hopefully, if we cut back over to the program, hopefully you don't have any orange errors. If you have any errors, what you're going to need to do is kind of just double check through and make sure there's nothing missing. I can show you a little bit about how this all works out. So we're defining. Everything should look exactly the same. Programming is an exercise in detail orientedness. So you have to make sure that everything looks exactly the same. There are no extraneous things in here. If there's something missing, then that's what's not going to make your program not work. So we've defined our pins. In our setup, we've started our serial, which should work from last video. We've set up our pin modes. We have semicolons at the end of every line. And in our loop, we have our drive forward, drive back, semicolons, and then our functions should look exactly like this. So you can kind of double check through everything. If it doesn't work, you can pause the video at any point, rewind, go back, and double check and find exactly what it is that doesn't work. So let's go ahead and finish this particular video up. And we'll finish it up kind of with watching what our serial monitor does here too. So you can see that even though our robot wheels are not running, this program is actually still working. So it'll be going forward and back continuously. And once we flip the motors back on, the battery back on, you can see that it actually is indeed still going forward and back. So you can see that it is iterating through. Now, one of the things that we can actually add into our program, which I think is probably important for a little bit, is probably a stop feature, because you definitely want to have a stop in there. So if we go and we kind of look back, if we look back in our little truth table thing right here, You can see that we have a couple of different ways that we can actually stop the car, which is kind of insane, I guess. So I think what we're going to try and use is probably the simplest one, which is this bottom one. Let's kind of see how it works. Now, full disclosure, I've not actually tried this particular method yet, so let's hope for the best. So what we're going to do is, based on this, we know that ENA and ENB have to be we have to be set to low. That's pretty much off. So let's go ahead and in our functions, we have turn right here. Let's go ahead and create our own custom function that says stop robot. So this is kind of how it works. So you type stop robot, your parentheses, and then you're matching curly brackets. And what we're going to do is we have ENA and ENB, which we have already in here. I'm going to copy those with Control C, and I'm going to go ahead and put those there. And we're going to set those both to low, and this should stop the robot according to their table. So the stop robot function is, I think it's important to be able to stop. You're going to need that. So let's go ahead and see if we can add this back into our code. Sorry, I think we had a false I was done, but then I realized we were missing. So stop robots. And then we're going to delay for another 1,000. Stop robot would be important, like, for example, if you're potentially scanning for things, maybe you want to stop your robot. So this is what should happen. Actually, let's put it in 2 places so our wheels stop forward and back. So what should happen if you're reading the code, you drive forward for a second, you stop for a second, drive back for a second, and stop for a second. So as opposed to what our wheels did last time, what they're doing right now still is they continually move. So when we upload this to the board, we're forward, stop, backwards, stop, stop, backwards, stop. So that actually does work the way that we did. Now, we forgot one thing, of course, because I always forget one thing. We have this print statement for our serial monitor that we're going to change up. So now when we run the serial monitor and we just re-uploaded our code, forward, stop, backwards, stop, forward, stop. That runs the way that it should, and it very accurately completes that. So this stop robot here is the last thing we add. And now we have actually all the movement things that we really need. And you can probably complete some of the challenges with just some of this code if you apply it in the right way. So that's our base robot program. And the next one, we're going to control the servo and have the servo be able to move and scan.